In my home state of Arizona, it took a Fitbit user 50,000 steps to the bottom of the Grand Canyon. Now, every step this hiker took, and you and I take every day, requires that our hips repeatedly absorb the impact as our feet strike the ground. Over a lifetime, this wear and tear on our hips can evolve into unbearable or even debilitating pain. But fortunately, surgeons offer relief in the form of a total hip replacement, where damaged cartilage and bone is completely removed and replaced with an artificial implant. Today, hip implant materials seek to minimize wear generated from daily use. Think about how the Grand Canyon was formed by the Colorado River eroding away its riverbed. Likewise, microscopic features or roughness on the artificial ball and cup joint interact during activities such as walking and can dislodge particles known as wear debris into your tissues. Ceramics have been used in hips since the 70s. Now, this is because their high hardness and strength allow their surface roughness to be polished away completely to a mirror-like finish. As a result, ceramic implants produce the least wear out of all available hip implant materials. But think back to a time where you might have dropped a ceramic or porcelain mug. Though incredibly rare, impacts such as a fall can result in the catastrophic brittle fracture of a ceramic implant inside the body. To prevent fracture risk, manufacturing has to rely on extreme heat and pressures, but these are very expensive manufacturing processes, and as a result, high cost of ceramic implants has limited their use despite their superior wear performance. But luckily, this is where my research in additive manufacturing comes in. Additive manufacturing, also known by its subset of 3D printing, is based on the principle of adding material rather than removing it. In this way, we lower manufacturing costs by minimizing material waste and reducing energy inputs needed to shape a part. But since additive manufacturing is a brand new technology, it's very important to show additive ceramics behave equivalent or better than traditional ceramics long term. My research does this by performing wear tests, adding weight to moving ceramic pins. If you can think about how a pencil behaves as you write, over time the pencil dulls, and we can measure the amount of material lost based on the size of the circular flattened tip. My experiments have shown certain additive ceramics produce 92% less wear debris, opening up new doors for development. Picture again the Grand Canyon and its alternating mineral layers. Layer-wise technologies gives us the ability to control and design ceramics such that the top layer is for wear resistance and the core layers prevent fracture. These are the first steps we are taking towards safer, more effective ceramics for the next generation of hip implants.
Our third student this evening will be Kevin Sanchez. Jessica, congratulations on your work. You told us earlier you have a superpower. Why don't you tell us about that superpower?
I believe I have several superpowers, but they involve Excel spreadsheets, list making, and small event planning, as some of my colleagues know.
So do you have any big events you're planning in the near future?
We hope to do why am I blanking on the word? A Maui night. We're going to hopefully watch Mamma Mia, so something more tropical in this horrible weather.
It sounds like a nice break. Thank you so much.